This presentation contains a brief introduction to the nomenclature of organic compounds, which contains different functional groups. The first group of compounds are compounds which contain the OH group, it means the hydroxy group, and these compounds are called alcohols. In case of aliphatic compounds, both linear or cyclic, the name of the compound is created by using the name of the hydrocarbon and the suffix OL. In case of hydrocarbons, which are longer than two carbons, it is necessary to define the position of the hydroxy group by the locant. Again, we use the known rule of the lowest possible locant. We can look at the examples. The first example is ethanol. There are only two carbons, and it is clear that in this case, it is not necessary to define the position of hydroxy group. The different situation is on this example. We have a three-membered chain, and it is necessary to define if the hydroxy group is on the carbon number 1 or 2. In this case, is on the carbon number 2, and the name will be propane 2-ol. In this case, the carbon chain of 8 carbons, due to rule of the lowest possible numbers, this carbon which have the hydroxy group will have the number 3, and the name will be octane 3-ol. In case of two or more hydroxy group are used multiplicative prefixes. In this example, we have two groups and 8 carbon chain. We number it using a lowest possible number rule, and we see that the hydroxy groups are on the carbons number 3 and 5. Thus, the name of this compound is octane 3,5-diol. This is the multiplicative prefix. In case of cyclic and aliphatic hydrocarbons, we also use name of the hydrocarbon and the prefix OL. There are two examples. This simple one, this cyclohexane, is the hydrocarbon. It means the name of this compound is cyclohexanol. It is not necessary to define the position because this carbon have to have the number 1. In case of two hydroxy groups, again, it is necessary to number it, and the name of this compound will be cyclohexane 1,3-diol. On this slide, you can see the aromatic alcohols, which are generally called phenols. The benzene ring with one hydroxy group is called only phenol. In the second example, we have bromine at position number 3 relatively to the hydroxy group. It means that we have to use locants. The number of this group, because it's the principal group, is 1, and this carbon has number 3. It means that this compound is named 3-bromophenol. Analogically, we can name this compound with nitro group, which is at the position 2 relatively to hydroxy group, and this is the reason that the name of this compound is 2-nitrophenol. In case of this compounds, because there are only two substituents on benzene rings, alternatively, we can use the name meta-bromophenol for this compound and ortho-nitrophenol for this compound. In case of more hydroxy groups, it's used the same system as in the case of aliphatic alcohols. Multiplicative prefixes, name of the hydrocarbon, and the suffix OL. It is seen on this example. We have here two hydroxy group which are relatively in position 1 and 4, and here in position number 2 is a methyl group. This is the reason the name of this compound is 2-methyl benzene 1,4-diol. Next two examples are naphthalene with hydroxy group. The difference is the position of the hydroxy group, and this position is numbered by the locant 1. It means that this, 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 and this position can be numbered as 1. Never uh, can be numbered as 1 this carbons and this carbons. It means it is naphthalene 1 all. In this case, this hydroxy group is at position which cannot be numbered by the number 1, and the lowest possible locant for this position is 2. It is, and the same is also for this carbons. This is the reason that this compound is called naphthalene 2-ol. I also would like to mention the most important compounds which are named using trivial names. And these four compounds, they are only examples because we know more uh, compounds from the group of alcohols or phenols which are named as trivial names. And these compounds are very often named by their trivial names. You can see that this compound, it is a very simple alcohol, 2 carbons and 2 hydroxy groups. Systematic name is ethane 1,2-diol, but very commonly it is used the name ethylene glycol. Similarly, this compound with a 3 hydroxy group, which is systematically propane 1,2,3-triol, is called glycerol. In the group of phenols, we have benzene ring, which is substituted by 2 hydroxy groups, and these groups are relatively in position 1 and 3, or also we can use the system that it is in meta position. We call this compound resorcinol, and if the position of hydroxy group are 1 and 4, it means that it is para position. This compound is called a hydroquinone. The next group I want to mention are aldehydes. They contain this functional group, and their nomenclature is slightly more complicated than the nomenclature of alcohols. Important is if the aldehyde is linear or cyclic. In case of the linear chain, which contains the aldehyde group at the end of it, we use the name of the hydrocarbon and the suffix al. This compound with 3 carbons is called propanal, and this, which contains 6 carbons, is an hexanal. This is not necessary to use locants because the uh, aldehyde group may be also only on the first carbon. In the case of cyclic derivatives, it means that the aldehyde group is directly bonded to some cyclic hydrocarbon. We, in this case, use the name of the cyclic hydrocarbon and suffix carbaldehyde. It means that this compound with the cyclohexane ring is called cyclohexane carbaldehyde. And know some important trivial names. The simplest aldehyde is called formaldehyde. The second simplest, the 2 carbon one, is called acetaldehyde. And this 3 carbon or compound which contains one double bond is called acrolein. The next group, which is very similar to aldehydes, are ketones. In fact, the functional group is the same. Important is that it cannot be on the first carbon on the chain because in this case, it is aldehyde. For the nomenclature, we use a name of the hydrocarbon and suffix ONE. In case of linear chains, which are long 5 or more carbons, it's necessary to use a number the locant. It can be shown on some examples. This is a four-membered chain, and the name is butanone because this carbon has number 2. If this group will be on this carbon, again it will be 2. The different situation is in the second example. There is the chain of 8 carbons. We have to number it using the rule of lowest possible locant. It means that this carbon is number 3 and the name is octane 3-one. In the third example, there are two ketone groups. We number it, we number the chain using again the lowest possible locant rule, and we use a multiplicative prefix. Then the name is octane 2,6-dione. The last example is cyclic ketone, and again the nomenclature is simple. The name of the hydrocarbon and the suffix cyclohexanone in this case, and there is not necessary to define the position because here is every time number 1. Here I will mention some trivial name. Trivial names, this is the simplest ketone which is possible. It is very known solvent which is normally called acetone. This benzene ring containing compound is called acetophenone, and this cyclic diketone is called benzoquinone. And now we have to name compounds which contain a functional group which is called carboxylic acid. The nomenclature is slightly similar to the nomenclature of aldehydes. It means that we use different suffixes based on the kind of hydrocarbon, if it's linear or cyclic. In case of linear hydrocarbons, it is again very simple. We use the name of the hydrocarbon and suffix oic and word acid. There are two examples. This is the acid which contains 4 carbons. It means that it is butanoic acid. And this acid which contains 6 carbons is called hexanoic acid. In both cases, the carbon of the functional group has a number 1. This is in the case that we use this suffix. If we have the principal hydrocarbon which is cyclic and directly on it is bonded to the carboxylic acid group, we use the name of the cyclic hydrocarbon and suffix carboxylic acid. It means that this compound is called cyclohexane carboxylic acid. In the group of carboxylic acids, there are a lot of compounds which are commonly named using trivial names. And knowledge of these trivial names is very important, of course, for the chemists, but in fact also for pharmacists. If you look on these first examples, the most simple acid is called formic acid. The 2-carbon acid is very known acetic acid. In case of aliphatic carboxylic acid, it is called propionic acid. In this case, which is the linear aliphatic acid containing 16 carbons, it is called palmitic acid, and if it contains 18 carbons, it is called stearic acid. As I said, there are a lot of compounds named by trivial names in this group, and here in this row we can look at the dicarboxylic acids. The most simple one is called oxalic acid. This one, which contains three carbons, is called malonic acid. These two acids, which are also dicarboxylic acids, uh, differs only in geometrical isomerism. It means geometrical isomerism on this double bond. If the configuration is trans, this, this one, it is called fumaric acid, and if the this derivatives is cis, it is called maleic acid. Next important group are aromatic carboxylic acids. This basic acid is called benzoic acid. These two acids are diacids again, and if the carboxylic acid groups are in position 1, 2, relatively, the acid is called phthalic acid. If the position is 1 and 4, it is called terephthalic acid. And the last one in this group is the acid which is very important for pharmacists, with one carboxylic acid and one hydroxy group in the position 2, and it is called salicylic acid. On the last row, we have the some various derivatives. This three carbon acid which contain this double bond is called acrylic acid. This uh, linear and aliphatic carboxylic acid containing one hydroxy group is called lactic acid, and this dicarboxylic acid with two hydroxy group is called tartaric acid. And on this slide, we will continue with derivatives of carboxylic acids. The first derivative I want to mention here are chlorides of carboxylic acids. The typical group, the functional group, looks like this. And the most simple method how to name this kind of derivatives is to using of the name that it is chloride of some appropriate acid. It means that this is derivative of propanoic acid. It means we can call it chloride of propanoic acid. This is a derivative of a cyclopentane carboxylic acid. It means that we can name it as a chloride of cyclopentane carboxylic acid. The systematic name of this kind of compounds is that we use as the root of the name of the principal hydrocarbon, and add the suffix OYL. It means that this compound, which contains four carbons, is called butanoyl chloride, and this with six carbons is called hexanoyl chloride. I would also like to mention two trivial names which are widely used in these groups. This, it is chloride of benzoic acid, or systematically benzoyl chloride. It is this compound, and this compound, which is chloride of acetic acid, is trivially named acetyl chloride. Now will we continue with esters of carboxylic acid. Uh, this is the functional group. It means that it is obvious that it is derivative of some carboxylic acid. In this case, are acceptable two methods for their naming. The first is that we can name is as alkyl ester of some acid. For example, this compound, the acidic part, it is derivative of acetic acid. It means that we can call it ethyl ester of acetic acid. It is this compound because this part is two carbon. It means it is ethyl. The alkyl is ethyl. In this case, uh, again, it is necessary to distinguish which part is the former acid and which part is the alkyl. Uh, it may be distinguished according to the position of this carbonyl. It means this is the original acid, which contains four carbons, and this alkyl contains three carbons. It means that the alkyl is propyl, it means that it is propyl ester of butanoic acid. In this case, the original acid is the cyclopentane carboxylic acid, and this alkyl is only one carbon, it means it is methyl, and it is methyl ester of cyclopentane carboxylic acid. The second possibility is using of the systematic name, and we use, in fact, the uh, in the prefix is alkyl. It means that it is again this part of the ester, a name of the principal hydrocarbon of the acid, and the suffix OATE, or carboxylate in case of the cyclic derivatives. Let's look on the examples. We use the same compounds, but we will name it by this method. This is ethyl, and because this is from the acetic acid, it is acetate. In this case, we use a trivial name of the acid, in fact, because uh, it can be seen, for example, here that it is butanoic acid, and the systematic name is butanoate. It means systematic name of this would be ethanoate, but we use normally acetate. Here it is propyl, it is the alkyl, and butanoate. Butanoate means that it is from the butanoic acid. And here the alkyl is methyl, and cyclopentane carboxylic acid was the acid. It means it is methyl cyclopentane carboxylate. The last derivative of carboxylic acids I would mention are amides. Uh, Here you can see the examples. This is the functional group, which means that the compound is amide. And similarly as in case of esters, we have two possibilities how to name it. First is that we can name it as alkyl or dialkyl, because this nitrogen can be substituted by one or also two alkyls. It means alkyl amine of some acid. In this case, again, as in the case of the esters, it's necessary to distinguish the part of the original acid and the amino part. That is two carbon acid. It means that it is ethyl amide, because there are two carbons of acetic acid. Again, in this case, we prefer the using of the trivial name of the acid. In this case, it is systematic, more systematic. This chain is 3 carbon, it means it is propyl amide of butanoic acid. And similar here, there is only 1 carbon, it means that it is methyl amide of cyclopentane carboxylic acid. The second possibility is again more systematic, and we use N-alkyl alkan amide. N-alkyl, it is the part which is here on the nitrogen, and it is necessary to use this big letter N, because it is used instead of an locant. And alkan amide, this alkane, it is alkane which creates the acid. Again, in case of cyclic derivatives, the suffix is not only amide but carbox amide. Let's look at the same examples. This is an ethyl acetamide. In this case, we use a trivial name for the acetic acid moiety. It means we don't use the ethane amide, but acetamide. In this case, we name it systematically. Here is propyl, it is N-propyl, butane, because 4 carbons, and amide. And here it is the cyclic derivative, it is N-methyl, and it is cyclopentane carboxamide. Now we have here a group of compounds which contains so-called amino group. It means this basic nitrogen. Well, the nomenclature is simple. We use the name of the appropriate carbon chain or chains and suffix amine. According to the number of carbon chains which are on the nitrogen, we can distinguish primary, secondary, and tertiary amines. Uh, these are the primary, it means only one carbon chain on the nitrogen. It means that it is ethyl amine, butyl amine. It's very simple. In case of the secondary amines, there are two carbon chains on the nitrogen. The carbon chains may have the same length as here or different. In this case, if the length is the same, we use also the multiplicative prefix. It means that it is diethylamine because there are two ethyl chains. In this case, we have the chain which is called butyl and methyl. In this case, in the name, we use alphabet. It means the B is first, and this is the reason that we call this butyl methyl amine. And this is example of the tertiary amine, which contains three the same chains on the nitrogen. Again, we will use the multiplicative prefix, and it is triethylamine. In case of so-called aromatic amines, it means that the amino group is directly bonded to the benzene or other aromatic ring. They are called anilines. This is the simplest one. It is only called aniline. Again, it is a trivial name which is used for it. And this compound, again using the trivial name of aniline, may be uh, named as a 2,4,6 trimethyl aniline. For the purpose of this course, it is not necessary to go through the nomenclature of all possible functional groups in details. Here you can see the overview or examples of some other functional groups. The first one is in fact derivative of carboxylic acid. It is anhydride. This group containing the nitrogen bonded by the double bond to the carbon is called imine. This group, which is similar but with hydroxy group on the nitrogen, is called oxime. This functional group, which is in fact only the oxygen with two alkyls, is called ether, and the sulfur analog of it is called sulfide, the alkyl sulfide. The sulfur analogy of alcohols are called thiols. This group is a nitro group. This R may be both aliphatic or aromatic. Hydrocarbon, the same. R is here, and this is the group. It means carbon with triple bond to the nitrogen. It is nitrile. This group is called sulfonic acid because this is quite strongly acidic. Again, this R may be aliphatic or aromatic. Hydrocarbon. Sulfonic acids can create derivatives, for example, amides, and this is called sulfonamide. I mentioned here because it is quite important for pharmacists. And as an example of compounds containing metal in the molecule, here is alkyl magnesium bromide. This, if it's this alkyl, but it is not necessary to be alkyl, again, it may be also the aromatic ring, and generally these compounds are called Grignard reagent. A lot of compounds and of course also drugs contain some uh, heterocyclic ring, which means that it is a ring which contains not only carbon but some other atom. The nomenclature system of this kind of compounds is quite complicated, and it is not necessary to know it for this purpose. For your information, I would only like to show here the structures and names of the most important and of course simple heterocycles. For these simple and small heterocycles, the trivial names are used. You can see the trivial names here, for example, furane for this, or I don't know, pyridine for this kind of heterocycle. This Last heterocycles are slightly more complicated. They are the condensed benzene or other ring, and this is in fact mostly for your information. And most important, I think, are these first two rows for you. At this slide is some more complicated compound. It is compound which contains more functional groups, and it is only an example how can look the name of some more complicated organic compounds. It is uh, of course not necessary for you to know this before you start the study. It means that it is not necessary to be able to name this kind of compounds. It is only example how it looks. And for the conclusions, during this presentation, we went through the basic nomenclature of most important functional groups. And it was, of course, the basic system of the nomenclature. We mostly use the systematic UPAC nomenclature, but very often I've mentioned the trivial names, which are in some compounds preferred and very widely used.